All right, so these are the notes on tangent lines and limits. So it's more of a review than anything else of things that we have learned and just looking at it from a different perspective. So this first sentence here says the equation of the function graph to the right is f of x equals, and then it gives a rational function. The coordinates of the hole on the graph are at negative 3, 7, 6. So you can see right here, there's a hole in the graph right here, and this point is negative 3, 7, 6. All right, so we have some pre-calculus statements. So when we say these are pre-calculus statements, these are statements that we would say out loud. This is how you could write them. So it says as x approaches negative infinity, the graph of f of x approaches. So if you look, basically we are looking at the end behavior and what's happening as our x values get smaller. As you look, there's an arrow that's leveling off and it's getting closer and closer to that asymptote, which is at 2. So we know that f of x approaches 2. How we write that in calculus is the limit as x approaches negative infinity of the function, which it's called f of x, is 2. This is not something that's new to us. We did this first semester. We've been writing end behavior this way the whole semester. All right, next one is x approaches positive infinity, the graph of x approaches. And if you look once again, there's an arrow that's leveling off there. It's getting closer to the asymptote. So that's 2 once again. So our limit is going to be the same. I'm just going to copy and paste it here, but I'll change that as x approaches negative infinity to x approaches positive infinity. Next, as x approaches negative 3 from the left, the graph of f of x approaches. So if we look at where negative 3 is right here. And we're going to approach negative 3 from the left. So as we approach negative 3 from the left, it's asking us what y value are we getting closer and closer to, and that's the y value of 7/6. So how we write that is the limit as x approaches negative 3 from the left of the function f of x is 7/6. Next one, the limit as x approaches negative 3 from the right. So I already have that yellow line right there. Approach negative 3 from the right. The y value that you are approaching, 7/6. So once again, I'm just going to copy and paste this, but I'm going to change it to from the right. And to change it to from the right, I'm going to change this little minus sign to a plus. Next, the limit as x approaches 3 from the left. So let's find 3. 3 is right here, this asymptote. So let's approach 3 from the left. So as we follow the graph here, you can see that there's an arrow pointing down. So we'll say that's negative infinity. So we have the limit as x approaches 3 from the left of f of x is negative infinity. And then lastly, 3 from the right. So approach 3 from the right, get closer and closer to 3. Your y values are increasing, arrow pointing upwards, that's positive infinity. So once again, I use my old copy and paste or duplicate, and then from the right. Okay, so it's just a reminder of how we write calculus limit notation. Now we're going to look at a numerical analysis of limits of the same function. So notice it says given f of x, which is the same function as the one graphed above, use the table below to perform a numerical analysis of f of x as x approaches negative infinity and positive infinity. So here's the table with numerical analysis. And it says based on the values in the table, what are the values? The limit as x approach, or what are the values? So the limit as x approaches negative infinity. So if you look at our table right here, our x values are in the top row. And approaching negative infinity is looking this way. So we're asking, as our x values get smaller, what are happening to our y values? So if you look at your y values going this way, 1.906, 1.952, 1.990, 1.995, we're getting closer and closer to the number 2. As x approaches, oh, that's a typo. This is supposed to say positive infinity. Positive infinity, or just infinity. What's happening? So as we look to the right, as our x values get get bigger and bigger and bigger, so 50, 100, and I can look from negative 50 to 50 to 100. You're just looking for it to get bigger and bigger to 1,000. What's happening to your y values? So 1.906, sorry, because there's 0 right here. So 2.106, 2.052, 2.010, 2.005. We're getting closer and closer to 2. So how is the numerical analysis above related to the graph of the function on the front page? So if you look, we got the same answer. And if you look at what's happening at the graph there, there is a horizontal asymptote. So if you look, we have this horizontal asymptote. So the end behavior is following the horizontal asymptote. So we'll say end behavior is, we can either say getting closer and closer to, or yeah, I'll just say getting closer to, getting closer to the horizontal asymptote. So what can we gather from this? We can gather that if you want end behavior of a rational function, you can find the horizontal asymptote, and we know that that's what the end behavior is going to look like. It's going to get closer and closer to our horizontal asymptote. All right, next one. Given the same function, use the table to perform a numerical analysis of f of x as x approaches -3. So we have, based on the values in the table, what are the values of, and then you look at these, we have the limit as x approaches -3 from the left, from the right, and then what's the limit, okay? So we're gonna approach -3 from the left. So here's -3 right here, okay? So if we're approaching -3 from the left, we're looking this way and we're looking at the y values. We're saying what's happening to our y values. So it goes 1.259, 1.180, 1.168, 1.167. So notice that we're getting closer and closer and closer to 1.167, which is approximately 1 1/3, or sorry, yes, no, 1 1/6, which is 7/6. So we're getting closer and closer and closer to 7/6. Now, if we approach -3 from the right, so we're approaching -3 from the right, we're looking at our y values, you can see we're approaching that same value, which is 7/6. Since we're approaching the same value from the left and the right, the limit does exist, and it's 7/6. How is the numerical analysis above related to the graph on the front page? There's a whole or removable discontinuity there, right? So we're looking at, or approaching that -3 from the left to the right, it's approaching that hole. So notice at -3, it does say it's undefined, okay? But that's not the limit because we're getting closer and closer to the hole. So there is a hole, which we also call a removable discontinuity. In the graph at -3, in the graph at -376. All right, last one to look at. So using f of x and the same graph, complete the table to perform a numerical analysis of f of x as x approaches 3 from the left and the right. So this says find the limit as x approaches 3 from the left, and the other one is from the right. So let's approach 3 from the left. And we're going to look at our values, our y values, and see what's happening. So if you look, -18, -48, -498, -498. So as you look at these, they're getting bigger and bigger, and sorry, not bigger, smaller and smaller and smaller, like super, 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 super small, right? So if you look at that, and I say using the word small, I shouldn't say small. Like they're decreasing very, very quickly. And so I guess I can call it small, but -4,998, like it's going to keep getting closer and closer and closer, arrow pointing downward. That was a terrible description, but I tried. So that is -infinity. Okay, so the numbers are increasingly getting smaller and smaller and smaller. All right, now I'm going to approach 3 from the right. So I'm going to look this way, look at your y values, and they're getting bigger and bigger and bigger and bigger and bigger, right? So they're approaching infinity. Okay, all right. So next it says, how is the numerical analysis above related to the graph of the function on the front page? So as we approach 3 from the left and the right, if you look at what it was there was an arrow pointing downward and an arrow pointing upward. We had a vertical asymptote there. So there's a vertical asymptote. There is a vertical asymptote, which remember we call that an infinite discontinuity. on the graph at x equals 3. And that's this value right here. Okay, so think about it. If it's negative infinity, there's something pointing this way, and that would imply that asymptote. Okay, so now it says there is a typo here. I forgot to save the new document. So this is supposed to be -5 from the left and from the right. Okay, I forgot to upload the fixed doc. Okay, all right, so now we're gonna do this example 1. So it says, given this function, find each limit. So first off, we wanna find the end behavior. X approaches negative infinity, x approaches, that's another typo, positive infinity, I didn't notice. Okay, so I'll fix those before I upload them. This is a positive infinity. Okay, so I want to find those limits. So in order to find those limits of a rational function, I need to know where the horizontal asymptote is. So let's find the horizontal asymptote. Remember, to find the horizontal asymptote of a rational function, you compare the degrees. Okay, you have to look at the degrees. So the degree here is 1, the degree here is 2. The degree in the denominator is bigger. So remember, if it's numerator bigger, none. Denominator bigger, I guess that's what I'm saying is bigger, okay? Then it's y equals 0. And if it's the same, then it's a ratio of the leading coefficients. All right, so if we look at this, the denominator is bigger, so we know that there's a horizontal asymptote at y equals 0. So therefore, my end behavior is going to follow that horizontal asymptote, so that the limit as x approaches negative infinity is 0, and the limit as x approaches positive infinity is also 0. All right, next, I want the limit as x approaches -5 from the left, from the right, and then what's the limit? So what we're going to have to do here is that we are going to have to find any vertical asymptotes and holes to find out what those limits are, okay? Because I'm assuming it's either a vertical asymptote or a hole. So let's find our vertical asymptote and holes. We need to simplify that function in order to find the holes. So I'm going to factor it. So 2 times x plus 5 over x plus 5 times x minus 5. There is a hole in the graph. The hole in the graph is at -5 comma, and then I'm going to write my new function, which is 2 over x minus 5. So I'm going to plug -5 in there, and I get 2 over -10, which is -1/5. And then my vertical asymptote set my new denominator equal to 0, and I get x equals 5. All right, so now if I look to see what it's asking me for, I want the limit as x approaches -5 from the left. So I'm approaching -5 from the left. There is a hole there, so I know that I'm going to get closer and closer to that y value, which is -1/5. From the right, I'll also get closer to that y value, so therefore the limit is -1/5. If this was a positive 5 right here instead, okay, for all 3 of these, I'd be approaching that vertical asymptote, so the limit would not exist. All right, next one here, find the end behavior. Once again, another typo there. So that's negative infinity and positive infinity. So I need to know what the horizontal asymptote is in order to figure that out. So I'm going to compare the degrees. So the degree here is 2. So just don't look at the first term. Make sure you look at the highest exponent. The degree here is also 2. So that means it's a ratio of my leading coefficients. So that would be my horizontal asymptote is at y equals -10 over 2, which is y equals -5. So now I know that I am going to approach my horizontal asymptote in both directions. So -5, -5. Okay. All right, lastly, we have this table here. It says below is a table of values of a rational function. So it's telling me it's a rational function. Use the table to find the limits that follow. So I want the limit as x approaches negative infinity. So I'm going to look at my x values this way and say what's happening to my y values. If you look at your y values, they're getting closer and closer to 3. B, the limit as x approaches 3. So I'm going to look at 3 now. So the x value of 3. So I'm going to approach 3 from the left. So I can see it's going negative 10, 4,000. This way from the right, 1.9, negative 4,000. So it's going to a very big number, a very small number. So it's going like this, and then it's undefined here. So I can tell there's an asymptote there. So I know that this does not exist. Also because it's a very big number and a very small number, so they're not approaching the same value from the left and right. Negative 4,000 and positive 4,000 are not the same value. All right, I'm going to erase this so I can use it still. All right, the limit as x approaches negative 4 from the right. So here's negative 4. I'm going to approach it from the right. I'm going to look at these values. So it goes 4,000, negative 10, 4.9999. So I'm approaching 5. Now I'm going to do negative 4 from the left. So negative 4 from the left. 3.009, 4.9999. So I'm approaching 5. And then I want the limit as x approaches negative 4. So if you look at this, they match 5 and 5. So limit's 5. Now you might be looking at this and saying, wait, there's an 8 right here. So what you have to realize is that this is going to be a removable discontinuity. You are doing it correctly. So it might look something like this. And then there's a point up here, right? You're still approaching the 5, a value of 5 from the left and right. Lastly, the limit as x approaches infinity. So I'm going to look, my x value is going this way, look at these values and see what's happening. Negative 4,000, 1.9999, so that is 2. All right, go ahead and pause the video and try this last one on your own, see how you do. The limit as x approaches negative infinity. You look at your y values, they're getting closer and closer to 1. The limit as x approaches negative 1 from the left. So here's negative 1, I'm going to approach it from the left, so I'm looking at these values. So 1.002, 2001. So notice they're getting very, very big, and then it goes to undefined. So there's an asymptote there. So I'm approaching positive infinity. The limit as x approaches negative 1 from the right. So I look this way. So I have 0.33, negative 1, negative 1,099. So the numbers are getting very small very quickly. So negative infinity. The limit as x approaches 2. Let me erase all this stuff that I drew on this. The limit as x approaches 2. So here's 2. I got to go look left and right, and I'm going to look at my y values. So you can see that I'm getting closer to 0.333 from the left, 0.334 from the right. So 0.3 repeating is 1/3. Notice it says it's undefined. It just means that there's a hole there. Okay. The limit as x approaches infinity. So I'll look my x values get bigger and bigger. What's happening to my y values? So I have 0.333, 0.998, so it looks like it's getting closer and closer to 1. And then lastly, the limit as x approaches negative 1. We already did negative 1 from the left and from the right. Here's negative 1 from the left. Here's negative 1 from the right. Positive infinity, negative infinity, those are not the same, so the limit does not exist. All right, that's it for today's practice. You can go ahead and get started on the